role in space. Now, our space tour is actually semi-recorded in the sense that we take pictures and post them, and we'd post them on Jim Adams' website. So if you want to go to www.jimadamsworld.com, you'll learn more about the space tour. So here's Jim Adams. He's about my age, a little younger. He spent 10 years in industry, 27 years at NASA, and then retired in 2016 from NASA and started his own business. And he's been doing all kinds of stuff. But he and I interacted when I was head of planetary, and he was the deputy. And we use this slide for introduction, and then here's my introduction slide. So I retired from NASA in 2023, as you all know, and I was NASA Chief Scientist and Director of Planetary. All right, so here's sort of an overview of our trip. We landed in Cape Town, and then we went to Stellenbosch, and Karoo, Carnarvon, Bloemfontein, up to Johannesburg, and Pretoria was where the lunar conference was. So the last thing I did was interact at the lunar conference. So I had a certain set of goals. I wanted to see the Atlas telescope. Now, South Africa is really well known for its telescopes in many wavelengths. So I have to tell you, I probably saw 30 telescopes. Now, I'm not gonna go over everyone, but I've picked out several that I want to talk about. We'll talk about what's on the hill at the South African Astronomical Observatory. That's number two. And the Atlas telescope is on that hill. And then we're going to talk a little bit about the Square Kilometer Array, Meerkat, which is unbelievable. And then I presented a paper in South Africa, Pretoria, at a lunar conference. Now you can see the roads. These are sort of the main roads that are shown. But once we left Cape Town, by the time we left Stellenbosch in particular, we were on gravel roads. So we crossed Africa half the time on gravel roads. All right. So it's not like the United States where you can get on I-80 and, zip across to East Coast or West Coast at all. I mean, here's the view that we had. Those two love to drive. And I said, you can do just that. I'll just sit and relax. So, and they drive on the wrong side of the road. This is South Africa was a British colony, so they drive as they do in Britain. Anelda was fabulous. She loved to drive, so that was great. I wasn't crazy about it, but she loved it. All right, so here's the summary of activities. I mean, we started out in middle school classrooms. We gave public talks in Cape Town. We then went to Stellenbosch. They had organized their robotics class that they combined two classes, and we walked in and they wanted us to talk about NASA robots. Well, if there's two people that can talk about NASA robots, it's Jim and I. So we had a wonderful time talking about how NASA builds robots, what those robots do, not only today, but in the future. What we were going to do going to Mars with humans and how those are going to be really important. We ended up on the radio station. Actually, the little inset picture is Jim and I just getting ready to be interviewed. That went on for about 45 minutes, which is pretty long time in a radio environment. That was all set up, ready to go. Then we had more public talks. Now, what was really big at the time was an asteroid that was going to hit the Earth. So if you remember in November of last year, asteroid 2024, that's the year it was found, YR4, that's actually a code for a month and for a period within the month. So it's in November sometime. And it had a high probability hitting the Earth. And only through more and more observations did they actually begin to snake down the error ellipse that you create to determine if it's going to hit the Earth. Well, fortunately, it's going to miss the Earth, but the moon, it may actually hit the moon. And this is a pretty big asteroid. This is this is like would fit in University of Iowa's football stadium, just barely. Okay, and so it's gonna if it hits the moon, it'll be unbelievably spectacular. So they were involved in observing that and getting ready to get more and more observations. So it was a perfect time. It was in the news everywhere, so everyone wanted to know about asteroids and whether they should be worried and all that stuff. So we did all kinds of talks in that area. And then we had spent a couple days on a mountain, which is actually a big plateau, where the South African Astronomical Observatory, the SAAO, is located, and really got a wonderful tour of the telescopes. And that's where the Atlas telescope is. Then we got back on the dirt road and drove to Carnarvon. Carnarvon High School had an assembly. Okay, and we were the main attraction of the assembly. So we would go in and we actually gave a couple talks. Jim talked about space exploration, and then I talked about what we find out in the solar system, what would the tours were, and then we answered questions for like an hour. So this went on for from 5 o'clock to 7 p.m. in the evening, when the town, to save energy, turns off all electricity to the town.
Whoa.
Okay.
Good heavens.
So at 7 p.m., we were showing our last couple slides and answering questions. Power goes out. And Jim and I are looking at each other like, okay, what's going on? And the kids are, it's normal. This is what they do all the time to save power. Now, what we found out when we did this trip, and this is just half the trip, particularly at Carnarvon, is these kids in high school form clubs, and they had a physics club and a math club, and the reason why is they had their math teacher was very sick off and on and wasn't able to teach them much, and they had no physics teacher. So here they are trying to learn physics on their own. All right. Now, this is, to me, this is, just very sad. I had a wonderful Burlington High School had fabulous chemistry, physics. I mean, the physics class from, was really tough. Chemistry was really tough. I mean, we really had some rigorous courses in high school, and of course, math I could was easy for me, but math was also tough. So, Jim and I have been talking about going back to South Africa, particularly Carnarvon again, with a series of materials because we've been developing in NASA, and I have all those materials now, a complete set of math teaching objectives along with problems to be solved that all involve space.
Hmm.
So we've been talking about that. We'll see how that goes. Maybe we'll go back next year. From there, we went on to Blue Fontaine, and we were at a planetarium, which was absolutely packed. We had time to talk about space technologies. We actually ran a project for probably 100 students, and they would come every hour, and we would cycle them in, and this is 9:30 in the morning, and we left there like 5 p.m. totally exhausted. And the last couple things that we did, last couple hours we did, we were in the planetarium, for which we also talked about what's in the night sky and what is NASA doing about going to this place and that place and answering questions. Then we had another public talk. Um, Also at the end of that, we then talked late in the day, and then we went to Johannesburg, and that's where the Lunar Symposium was. Part of it was in Johannesburg one day, and then the other 3 days it was in Pretoria. And so when we were in Johannesburg, we had what we called NASA night. They knew former NASA people were going to be there, so hey, why don't you come and answer questions? And man, we were there for like 2 hours, maybe 2.5 hours. So, so we were, I was anyway, as you know, I'm no spring chicken anymore. I'd say that, truthfully. I was totally exhausted each and every day. So let's talk about some fun stuff. All right, things that I mean, it was all wonderful. It was all fun, but I mean, some things that I know everyone is going to be interested in because this is astronomy heaven. All right. This is absolutely astronomy heaven. So this is just an aerial view of part of the South African Astronomical Observatory. These are their really big telescopes. There's probably 15 other buildings off to the left, 15 other domes, all right, for which the Atlas telescope is one of them. And the really big one is the SALT telescope, which is sitting in the upper middle of the image. So their top telescopes are these. There is a 1 meter telescope that is SAAOs. All these are SAAOs, but they have specific purposes. They're typically built with other nations' money, along with South African money, along with South Africa management and taking care of these telescopes. And so, as you can see, the sky is just dead clear. It's just dead clear, and we're on a tall plateau, and you can't walk up this hill. You got to take a car. All right. So we stayed for a day, actually almost 2 days, down below in the astronomer quarters. So all the foreign astronomers that come there, they're we in the area. There's probably I don't know, 15, maybe 20 rooms that are hotel-like rooms. They're not really big. They're kind of Spartanish. It's almost like a dorm room, I'd say. And astronomers would come and live there for 6 months, 8 months, a year, and go up to the hill, which is this, every night and observe. So SALT is in the background. That is the South African Large Telescope, and that's a 9 meter telescope. Okay. So we're talking, 30 feet.
That's crazy.
It's huge. It's huge. And then there's another 1 meter, and then there's a 1.9 meter, and they all observe in a variety of wavelengths. There's some of these have specialized. Well, they all have specialized instruments that are being built by other countries or built by South Africa and installed and used on these telescopes. And so SAAO manages all these telescopes. They also do all the scheduling. They provide accommodations for all the foreigners coming to observe. And this is just a huge plateau. You can kind of look across if you look on the horizon just to uh, uh, the one telescope, Lasiti. You can see on the right a plateau, and that's what we're on. We're just on a very high plateau. And that's where these telescopes are. And they look in the ultraviolet, infrared, visible, and they do all kinds of stuff across the optical spectrum. Well, here is we toured most of the telescopes, and so here's the SALT telescope. Um, now you'll have to look carefully, but in the center is a picture I took from the top of the dome down on this 9 meter telescope. And it's made of sections. You can see some of the sections clearly, and then you can see reflections of the room on the other half of the telescope. So you have to look carefully, but there it is, this huge telescope. And then in the control room, you can see on the right, you've got the status of the telescope, what's on, what's off, the orientation, and then the data is taken and rolls into the data analysis room where you see this one gentleman who's working the telescopes. Okay, so this was spectacular. In fact, I have to tell you, going up in this dome and looking down at this telescope almost gave me vertigo. I mean, it just they had the slit open and the wind was blowing and you just felt unsteady on you're walking up a stair with hardly any railing and the stair steps are maybe a foot wide. So it's tight. It's tight. And there's the railing, this black railing right there. That's in front of you. So this was wonderful. As I said, we went to every telescope around. And here's the Atlas. Here's the NASA Atlas telescope. So Jim and I are there, and no unauthorized entry. We got authorized, which is great. It's our telescope, NASA's telescope. It's the US's telescope. So we went in and had a wonderful tour of the telescope by the people that manage this. And it was great. And that night it automatically opens the slit, moves the dome, and starts observing the entire night sky 3 times. All right. Takes pictures everywhere. And so it is really busy and it's looking for near Earth objects. Now, of course, I'll give you an example of some of the data. But one of the things that it observed, and it was the only NASA telescope that was really able to observe it that was on the ground, was the impact of the DART mission on an asteroid called Didymos. So DART was a mission. It was actually the last mission I got Congress to approve and got money for before I left headquarters. And the Applied Physics Lab built the spacecraft, and it was designed to crash on an asteroid and move it. Okay, so we decided the best asteroid to hit was one that was orbiting another asteroid. We didn't want to hit an asteroid and move it into an orbit where it would hit the Earth. That'd be really stupid. So we decided, hey, this is the best thing, and it's easy very quickly to see how the orbit changes by hitting the asteroid, slowing it down. Therefore, its orbit would get closer to its main body, Didymos. And so the concept was we will see how that orbit changes over time. And models suggested that the period, because it orbited the Dimorphos orbited Didymos every 11 hours, 55 minutes, we thought if we could get a slowdown of the orbit by 10 minutes, we'd be doing really good. Well, we got more than that. So here's a real ground-based telescope image of the impact. Okay. And it went from 11 hours, 55-minute orbit to 11 hours and 23 minutes. We had a 32-minute change. really, really blew our mind away. Okay. And here's the observations from Atlas. Okay. Now, I'm going to play this. This is a movie, and you'll see Dimorphos move across from right to left, and then you'll see the huge impact that will occur. So here it goes. There goes Dimorphos. Bam, and then we hit it. Okay, and you can see the debris field um, that results from that. And so the telescope was trained to just sit on it, sit on an area that was large enough that it would encompass this entire impact, which it did. And so for days, this asteroid leaked material. So we were just delighted to talk to the people running the Atlas, and I gave them a little present. I gave them a NASA memento, which they were very happy. We owed it to them anyway, and that I just had the opportunity to bring it, so that was perfect. Now, a day or two later, we went on, got on the road, and drove for God 6 hours between this one and the next one, out in the middle of nowhere. I mean, this is like driving in southwest desert of Nevada. And here we are at this, square kilometer array. Okay. So here's a couple telescopes. You can see them there. There they are, a couple of them sitting out there, and these are really big telescopes. But here's really what it looks like. All right. We were just by one of them. So
Wow.
all these telescopes are trained to work together to observe in the radio frequency area something of interest. All right. And they observe from 50 megahertz to 250 gigahertz. And so these are this is the square kilometer array, and it was just absolutely fantastic. We had an opportunity to go into the control area, talk to the people. They gave us tours on the inside, and of course, we could drive to certain sections only during certain times, and we had to take a special car, and the car had to be battery operated because a regular car, and it's shielded, but a regular car generates little bursts of radio frequency information, and that would screw up their observations. So that was really neat. And then also, in this area, and this is all near Carnarvon. This is why it's so surprising to me. We have all these scientists and engineers and everybody that's in this area, and yet Carnarvon as a town, where some of them might even stay, it's 60 kilometers away, but that's close. I'm telling you, that's close.
Mhm.
uh, they're dying for some real solid teachers and educational opportunities. Now here's the Meerkat telescope. So this is also quite a large array. You can see more of them here, and they also observe in the very low frequency area. And let me show you one of the most spectacular images that Meerkat has done, in my opinion, and that's this one. This is done by all those dishes working together over a several day effort. In fact, this might be a couple weeks worth of observations. And they're looking at the center of the galaxy in the radio area. So, the very bright spot in the middle is buried in that bright spot is the galaxy's black hole. And these streaks that you see, these streaks are high energy particles that are flowing down magnetic field lines. So you're just getting just little bitty pieces of the magnetic field lines as these particles go streaking down, generating radio waves that we then make measurements of. You also see um, off to the middle left, a cloud, and at the edge of the cloud are little bright spots. Those are stars being born. Those are all stars being born. And then you see these clouds. Also to the left, there's three or four clouds. Some are smaller that are above this nebula that's generating these new stars. And many of those are planetary nebula. They're stars that are at the end of their life and they've exploded. So they've blown off the outer reaches of their surface and into space, and they create these shells, which then make them look like they're all puffed up, make them look like a planetary body because they're you can see surface and structure. When in reality, they're not. They're a star that's blown out. It's layers all around it. So this is just a phenomenal set of data, and what Meerkat is really known for. Now, in Bluefontaine, I had a wonderful opportunity to go to another observatory. We gave a couple talks there and interacted with the kids, and they gave us a special tour of their of three or four telescopes on a mountain. And this is actually a well-known um, telescope area. And this telescope in particular is well known. This is a 13-inch Alvin Clark refractor, okay, built in 1887 and used by William Pickering to take the first color photo of Mars. Okay, and so there's the color photo blown up off to the side. Here's what it looked like in its own little dome. Since then, they have the dome has fallen apart, so they've created a new dome, and this is the telescope in that dome, and it's really got a wonderful history. You can so this thing on the wall, it really gives an overview of the telescope. And now they don't use it professionally, but they take tours and they use it for observing things with the public, just like you guys do. Getting local people excited about the world, that we live in outside of the planet Earth. And this is at the Boyden Observatory, and they call it museum, but it's really a working observatory. And there's three or four other telescopes that actually work on a daily basis. All right, so I told Judy I would just talk for a little bit, a little bit about some of the things that we're doing. I had an opportunity based on my company, Space Science Endeavors, to do the science research, and then got invited to talk about it. And as you can see, it sort of got out of hand.
That's so cool. Hmm.
So if I can answer any questions you got about that, and then I will start looking at some of the other questions you've sent in.
What altitude were you?
She
Oh,
asked.
yeah, what altitude? I don't know. It wasn't nosebleed altitude, but it was noticeable. I'd have to Google what the altitude would be of these areas. The real high place is not where Meerkat is. They're down in, they need a flat area down in the valley. All right. Square kilometer array and Meerkat are down in the valley, and the optical telescopes are what are on the hill. And it's a trek up. It's got to be at least 1,000 feet above the valley.
Hmm.
And it's flat. I mean, it is absolutely flat. It's like somebody just took sawed off the top of the mountain or whatever happened to it. And they're like
That's
that all over the place. So the towns are nowhere near. This is why you have to live at the observatory. Um, while I was there, there was a Japanese group. There was three from Japan making observations, and they're going to be there till November. And they'd gotten there just a couple of weeks before we did, so that was March to November. They have an observing schedule throughout that time that they're doing, and of course they're working on the telescope, bringing in new instruments, so they need to set it up and then do the observing, and then take it down and do other things, which is why it's more than 6 months long. It's over these time periods that they actually have to do the work. And these guys, that's all they do is work. If they're not sleeping, they're working. And that's what happens with really professional astronomers. Um, that's what they do.
Um, One of our librarians looked up what the
Ah,
altitude of Meerkat was. It's 1,000 meters, which is 3,300 feet.
yeah, and that's in the valley.
Yeah.
Yeah. So go up at least another 1,000 feet, and you're on the plateau where the thank you very much, where the salt and optical telescopes are, and where the Atlas is. And we got, and because it's desert-like, it's like the Southwest desert, like Nevada, the area, and big areas in Nevada, Arizona, in the heart of South Africa. Then they have little precipitation, no fog, maybe a little fog every once in a while, but no big deal. And that's all down below anyway. And that enables them with the observatory to do some really fantastic science.
Good question. Other questions? Oh, we have a question back there. Yes.
Do you think the project itself?
I'm sorry, can you say that again?
Do you think the DART project can stop an asteroid from hitting Earth?
The DART project can help stop asteroids from hitting Earth.
Yes. Yeah, so that project was designed to be our first test to move an asteroid. The key is we wanted to know how much we could move it. We learned a lot. We learned that we moved it far more than we thought we could, which means we now could hit a bigger asteroid. It also tells us we don't know a lot about the density in the interior and what we call porosity. The material sits together and it looks like, a sponge. There's plenty of gaping holes in it, apparently. And so even though it looks like a large solid body, there's a lot of it's not crunched down. There's a lot of space inside it. And so when we hit it, the momentum transfer worked great. Now, Didymos is 160 meters. If 160 meters hit the center of Washington, D.C., it would take everything out within a diameter of about 70 kilometers. Everything. It'd be rubble. And then the next 70 kilometers around that would be whatever could stand the pressure wave that would blow by, and whatever fires started, et cetera, et cetera. So the next 70 kilometers would be partially destroyed, survivable. Inside that first area, it's not survivable, but you could get out beyond that and get it survivable. Just to give you an idea what that is, if you know Washington, D.C. area, it's surrounded by a ring road, and that ring road is called the Beltway. So everything inside the Beltway would be destroyed, and then the destruction would lessen as you go out. So 160-meter asteroid, and we think there's about 30,000 of them we have to find that cross our orbit. 30,000 of them. And it's not a matter of if, it's only a matter of when they're going to hit us. Now, they've been hitting us all the time. before, humans have been on this really started, to recognize what's happening, um, in the last 10,000 years, agriculture started 3,000 years ago or four. We started writing. And that time period is nothing in terms of the long age of the Earth. And so the Earth's been hit in the ocean and, in the land, all over the place. And these are regional destructive areas that over a few years recover. And in fact, we've ran around Earth and we can see where the impacts have been because they've been covered up by vegetation, by erosion. We don't see any in the ocean, of course. The Chicxulub is the area in the Yucatan Peninsula in Mexico where the 6 kilometer NEO hit the Earth and is believed to have created such a blanket of dust all the way around the Earth that the killed the basic parts of the food source for the dinosaurs, and so they largely died out. 80% of the species on the planet died out. So um, the DART mission really was incredibly important to test. We've never done anything like that before, but now we know it's a good one and it's going to work. And we're thinking about some other things that we need to do to get ready.
Good question.
What are the odds that and that one of these asteroids are hit in any given year?
Yeah.
Yeah.
So statistically, we get one of these big ones every 20,000 years. Yeah, every a city killer. Okay. We'd get something that could destroy a couple states, something bigger than that, half a kilometer every million years, and so that rate is going down because we're sweeping them out. But Jupiter is the one that is throwing the asteroids out of the asteroid belt and throwing them towards the Earth or throwing them out of the solar system. So the source region is the asteroid belt, and there are probably 3 million objects we need to watch out for there. But they're there, they're far away. We only have to watch the ones that Jupiter throws in at us. So we've been looking for them for the last 25 years and found pretty much half of what we need to find. And in another 15 years, we'll probably find the rest of them because NASA's planning to launch a telescope to go up and find them. And so I ran that program as planetary. So in 2006, we had $4.5 million to find all the NEOs. Well, that's ridiculous. I can hardly rent time on a telescope or two or three telescopes to do that. And I worked the budget up to $150 million in 12 years, and that was enough to build the mission to do the mitigation. And in the meantime, we started doing all kinds of other things with other telescopes, building the atlases, getting them down in various areas. We got now 4 or 5 of these all over the place. Hawaii's got one. South Africa's got one. So we're distributing them in both the northern and southern hemisphere. But it's going to be a constant problem, and we got to we got to really keep watching it. If we don't, we're going to lose out, and that'll be a bad day. The dinosaurs didn't have a space program. Since we do, let's use it, right?
Right. Thank you. Questions? What do you think?
So technology is just maybe like just in our world. So I can't imagine technology system. In the future, what's really exciting? What's coming up? What gets you excited going forward? All the advances and things that are coming.
Okay. there is really a bunch of stuff going on that I'm really excited about. Okay. And it's all over the place. I like science in many different fields. So you can almost name a field, and I can tell you what I'm excited about. So in the area of astrophysics and astronomy, to me, it's all about the exoplanets. You know, when I graduated at the University of Iowa, and I was an optical astronomer as an undergraduate. I used their 24-inch telescope to do all kinds of stuff when I was an undergraduate. And then when I started my graduate career, I thought, gee, I could do astronomy from spacecraft. Why would I do that crazy schedule of sleeping during the day and working all night like these poor guys do at these observatories I was at? I would have been one of them. So uh, the space age really, came at the right time for me to get interested in that, and so the exoplanets are we're moving so fast on those that I think maybe in 10 years or so we might be able to find hints of life on an exoplanet. That's really exciting. In the area of planetary science, I think we have indications that there might have been life on Mars. Everything we've been doing gives us some sort of positive little, oh yeah, that looks familiar. Okay. And that life may have is gone. There's no life on the surface, but it may still be there. But it's in the crust. It's underneath the surface. So we now know where to go and where to look for it. And we need to bring those samples back because that'll tell us for sure that Mars had past life. So I think our ability to determine life in the solar system is going to be at Mars, and the other big possibility is Europa. And the next to the last thing I did before I left NASA was get the money for the Europa Clipper. And so that mission's already built, launched, and it's on its way to Europa. And Europa is this fabulous moon with this ice shell with an under crust ocean. And I'll come back, whenever you want me to, and we could talk about some of those things like that. We can talk about Europa or Titan or some of the others. So planetary science has got all kinds of fabulous things in that. Lunar science, some of these telescopes, these radio telescopes that we need to do, we need to now go to lower frequency, and the only way to do that is go to the far side of the moon. We need a square kilometer array on the far side of the moon. Now, what we can do with that is phenomenal. It's all about looking back further into the universe than James Webb does, determining right after the Big Bang how matter came into being, what some of the early emissions that were generated by the formation of hydrogen. And an array can tell us that and where that happened and what the distribution is. In addition to that, it can make measurements of radio emissions coming from aurora on exoplanets. So that can tell us about planetary formation and how these planets have magnetic fields just like we do. And that's one of those things I use to check box A that we want to know more about those planets because it's most Earth-like because it has a magnetic field like us. And if it's Earth-sized, and in the right area and has all the other things, that would be a good candidate to look for life. So that's one of the areas. Now, on the on the indoor sports, we call it indoor sports. Well, what's indoor sports in space? It's the International Space Station. Now, now, what's going on there is I actually am working with Oxford, and this is in England, and I have gone there now several times. In fact, Diana, my wife, was really pissed at me that I was gone as long as I was, and I was telling her what I knew, and they kept adding dates to that. And I had just come back from England after a week and a half. And then I turn in February, and then I turn right around and leave in March. So I was in the doghouse for a while. But what happened is we got an experiment up on the International Space Station. It was launched in April. It's been installed on the ESA module, and it's a box about like this, okay? And it sits on top of a NVIDIA backplane, so it's got a mini supercomputer. And what do we have in it? We have 6 vials of organoids, and organoids are cells, all kinds of all conglomeration of cells from the same organ. So we have cartilage cells from a knee and ligament cells that connect to that cartilage. So those would be called, and they're different cells because they perform different functions. One's a ligament, one's cartilage. Why are we doing that? Well, these cells are floating in a plasma, like blood plasma, and we're injecting them with nutrients. And the nutrients we expect the cells to bring in and kick in a process called autophagy. When you go to space, the process called autophagy in our bodies stops. Autophagy cleans up a cell. When a cell creates material, the DNA asks the RNA, go create this protein. The RNA creates the protein. Then the DNA says, now you made it wrong. Autophagy is supposed to break that up and get rid of that and have it start over. But autophagy that stops ends up having that cell accumulate crap that it doesn't use. And when that gets so big, then the cell says, okay, it's time to die. And so it is an aging process. So what happens in the cell, you build up this material, you get inflammation, and then the cells start dying, and you have organ failure, and all that stuff happens on Earth very gradually. In space, it happens in days. And we found this out from the twin study where we had an identical twin. One astronaut stayed on the ground, the other one we sent the International Space Station. And then we compared everything, even down to their DNA when they came back. And they were shocked, all the changes that occurred. Now, when Scott Kelly came back and he had all these, he lost most of his immune system. I mean, he's like 48 years old, maybe 50 years old when he did this. And now he's like a 70-year-old. You know, I'm probably more healthy than when he was when he came back. And so consequently, his body started repairing everything that it lost, which is great. Now we have a way to then go to space, understand the role gravity plays, and use that environment to do aging experiments. So this is an aging experiment. We've got 6 drugs we're trying, sets of nutrients, and we've got positive indication that a particular drug really might have started or restarted the autophagy process. So this is important for space travel to Mars just as well as it is here. Imagine if we can take a drug and be able to rejuvenate our immune system. If we had done that research before COVID, we wouldn't have had anywhere near the deaths we had. And our lifespan would probably be at least 10, maybe 15 years. And I'm talking a lot more about quality of life too. If the cell doesn't accumulate crap and you don't end up with inflammation, you reduce inflammation and keep your cells healthy, and then they keep dividing. And then there's other limits to life that kick in. I mean, you die through a whole bunch of processes. But this is an experiment where we're going after one of these processes and taking a look at how to reverse it. But it will give a better quality of life and a longer life if we can work this out. And that research is going on right now. And when I was in Oxford and I gave several lectures and did all kinds of things, and I helped them get on International Space Station, which is why I was part of the project. I kept telling them, look, you can't do this soon enough. Let's get going on it. I'm not getting any younger. So that, all these areas are just fantastic, that's going on.
Good question. Have any other questions?
Okay, yeah, I have a set that are here. I can shoot through these real quick.
Yes.
Okay, yeah, one of them is, do you have a favorite planet? And if so, which one is it and why? Okay. So I was head of planetary science for 12 years. And every year I would be asked to give a lot of public talks. And I loved doing that because I could talk to people about things that we're finding out. I mean, this is your money, my money too, that we pay in taxes, and this is what you get for it. I want to tell you the fantastic things that are happening because it's really worth doing. And so I would talk about all the planetary science, and it without fail, I would have a young child come up to the microphone and ask me that question. What's my favorite planet? And so here would be my answer. I'm head of planetary science at NASA. I would say I love all my children equally. I don't have a favorite. Now, the parents would laugh and the kids would be confused and, well, why don't you have a favorite? And the reason why I don't is every mission we do to go to one of these solar system bodies has blown my mind. I mean, the things that we find out, nothing is mundane. When we go there, we know nothing or virtually nothing, and then we find out all this fantastic stuff. And so they each, in their way, are giving up their secrets, and that to me just makes them really exciting. They all play a role. Mars is very much like Earth, but it's so different only because it's slightly smaller and it's a little further away from the sun. Other than that, if it was in our orbit, it'd be like us. It'd be teeming with life. So, uh, all these little differences that come up are for a reason. And then by doing the science, we figure out what that reason is. And that comparative planetology is really important. Now, I was working at Goddard Space Flight Center when the National Science Foundation calls us up and says, uh, we'd like to have you check your data on ozone. We're down in Antarctica and we have an ozone experiment on the ice, and it requires looking up. And when we look up, we see no ozone. And therefore, we think it's broke. Can you tell us if there's ozone above our experiment? Well, that was a pretty good question. Now, I wasn't an Earth scientist. I wasn't on the Nimbus mission. I wasn't on the instrument that was making these measurements, the TOMS instrument, but I had all the data. I was head of the National Space Science Data Center. So the project came over and said, can we pull all the data out of the archive and take a look? Because we can tell the National Science Foundation there's no ozone above them. And that surprised us. And we want to know how long that's been going on. And so we started looking, and indeed, every year there was a hole that was just getting bigger and bigger and bigger and bigger. Now, the ozone is a very important layer in the atmosphere because it absorbs ultraviolet light. Ozone is three molecules of oxygen stuck together. And it's at 20 kilometers above us. And it has a very special distribution. Any ozone you destroy in one place, ozone all around it fills it in. And what ends up happening is you redistribute the ozone, and all the ozone from the poles gets pulled in to fill in the holes. So the hole, even though it's over Antarctica and the North Pole, is really being filled in by over the United States and over China and over all these other countries that are destroying ozone above it, and the ozone just fills it in and then takes it from the higher latitudes. And so the dynamics of the movement of ozone in that 20 kilometers is very different than what we have here in terms of our atmosphere and how it does what it does and all that stuff. And so then the scientists went crazy. What's going on? What's going on? How do you destroy ozone? And so what happened was you go into the literature and you pull out all these papers, some by Carl Sagan on the destruction of ozone at Venus. And it's done by chlorine. And therefore, what's the chlorine in our atmosphere? It's coming from aerosols, CFCs, chlorofluoral uh, uh, compounds, or whatever the other C is. And the first C is chlorine. So we're generating the chlorine, and that's what's destroying the ozone. So we used what we knew about what was happening on another planet to figure out what was happening here. Pretty neat. And so that started, the international negotiations, and CFCs were banned. And now they keep monitoring the ozone. Now, what I got to tell you is it has started to close, and now it's starting to open up again. Okay. Why is that? Well, there are some nations that are going back and generating CFCs and violating the treaty. And we're seeing it. So, we got to do a better job internationally to work together, because it doesn't make sense to destroy the world based on foolish acts by certain countries. So, the Earth scientists are all over that, and they think they know where it's coming from, and it may have been mitigated by now, but it just goes to show you comparative planetology is really great. That's why I have no favorite planet. Okay. All right. Now, let me go to the next question. How long have I got? Have I got talked a little longer? Yeah.
Anything?
So go
I
ahead,
think
Judy.
maybe till quarter till.
Yeah, that'd be great. I'll go through these a little quicker then. What are your thoughts on Planet Nine in our solar system? I think it's out there. Now, Planet Nine, let me remind everybody, we used to have 9 planets. I mean, that's what I learned in grade school. And I'm looking out there, and I think you all did. If you weren't in my class, you were, after me. You that's what you learned. And they decided once they started seeing Pluto-like objects beyond Pluto, and I mean, there's probably tens of thousands of Plutos beyond Pluto, and we're finding them like right and left. We found probably close to 3,000 of them now. And so rather than call them planets, the astronomers wanted to call them dwarf planets. So the real idea is there another large planet in the outer part of our solar system? Computer simulations say yes. What happened early on in the formation of our solar system is that Jupiter, just like it throws objects out of the asteroid belt because of its gravitational tugging and pulling, it did so of another planet. And it's a Neptune Uranus sized planet. So it's like 10 Earth masses, and maybe four times the diameter of the Earth. It's a big, really big planet, and but a gas giant, and it threw it out. Now there's plenty of indications that happened. Now that we know, now that the computer simulations say, hey, we ought to be looking because of this, and this. We then can look back and say, yeah, that's right. The sun is actually cocked. The ecliptic is not exactly perpendicular. There's scattered Kuiper belt objects of an object that must have gone right through that area, just pushing them out of the way. I mean, just a whole bunch of evidence. So either it's completely thrown out, which makes it a rogue planet, a planet orbiting the galaxy but not orbiting a star, or it's way out there. And if it's way out there, it may be like 600 AU to 900 AU, where 1 AU is between the Earth and the Sun. So, I mean, it's really out there. So, there's several astronomers that are looking for it. So, in I don't know 2016 or so, when I was head of planetary, and they did a bunch of simulations, and Mike Brown, who's a good friend of mine, is really leading the charge of finding it. I called him up and I said, I want you to find it. Do whatever you can to find it. I want to find it while I'm head of planetary. Well, they haven't found it. So it may indicate it actually left the solar system. But indeed, there's a lot of evidence that it's there. Okay, could Mars be used as a relay transmission station for Kuiper Belt probes? Yeah, now Pluto is a Kuiper Belt object, and it is one of a member of a whole series of objects that are Pluto-like. That's what I was talking about. There may be at least 10,000 of them. We found nearly 3,000 of them. Mars is going to be used as a relay for a bunch of things. If we mine things in the asteroid, we're gonna build things on Mars and then go to the asteroid. We won't go to the asteroid belt from Earth. It's too difficult. But you can do it from Mars much easier. So several of these shows called what was the name of the series where they're mining stuff out in the asteroid belt? Oh, what the heck? What's the name of that?
Oh,
I know the show, but
we have some heads nodding, but we're not sure what the name is.
Yeah. Just a sec. Let me look at something. Maybe I can figure it out.
That's it. That's all.
it was a pretty good
Very
sci-fi.
good name for the show.
Yeah.
It was a pretty good sci-fi show too. I liked it. They're on Cirrus.
Yeah, right. I forgot the name of it. Engage or something. But in any event, that actually has some legs in the sense that that may be what happens in 100 years. So Mars is going to be used for a lot of stuff, not just as a planet that we can live and work on, but that will be a good relay in many different ways. Okay, my thoughts on Lucy and the Trojan moons. Okay, so what are the Trojan moons? We also actually call them Trojan asteroids, and they're hanging around Jupiter. They're in Jupiter's orbit, but they haven't fallen on Jupiter because they're in a gravitational null. And that gravitational null is on either side of Jupiter. So as Jupiter moves around, it's carrying all these objects with it. And there's probably several thousand of them. Now, during the time that Jupiter threw this other planet out of the solar system, this material in the asteroid belt and in the Kuiper belt got mixed up. So we think what the Trojan asteroids are is a combination of Kuiper belt objects and asteroidal objects. And so Lucy is a mission that I helped select. It was built during my time at headquarters and launched to go to. It's going through the asteroid belt right now, but it's on its way to Jupiter's Trojan asteroids, which are on either side of Jupiter in its orbit, right in its orbit. And so it goes around the sun just like Jupiter does at exactly the same year. 1 year on Jupiter is the same as 1 year on these Trojans. So it's a fabulous mission because it'll tell us how mixed up these things got. Are they all asteroids or are they all Kuiper belt objects? Okay. My thoughts on a moon base. Yes, we're moving towards that, and we're going to go to the South Pole. South Pole's got plenty of resources. A lot of resources are in the form of water, and it's frozen, and it's in craters on the South Pole and the North Pole of the moon where the sun don't shine. When you think about what happens at a planet, in the North and South poles, if you have impacts, you have big holes, they end up being reservoirs of material. And anything that gets put in it stays in it. And we think a lot of water's there. And so that's the best place to go because I think any human exploration's got to have water, and we can't bring it all. Now, we recycle water on the International Space Station. I don't know if you knew this. So, in the morning when they get up and they have their coffee, and later on the day when they go to the bathroom, that water is filtrated and put back in the system. And the next day, they drink it again in their coffee. And so you lose a little, of course, because your body needs it. But in general, you reclaim a significant amount of water, like 70 or 80% of the water comes back. So that's cool. That's cool. But in this case, we're going to have to go there where we can get water. All right. The Voyagers and the 70 communication systems, are you surprised it lasted into 2000? Yeah, I am, and beyond. Um, uh, our spacecraft really are built like tanks. I mean, when I think of Voyager, I must have had 5 cars, and I don't run them all the time, and they're in the shop all the time, over time. And Voyager, is, it's going just like we built it. Now, it's not working completely correct in the sense that a number of instruments have died. They've turned off quite a few of the other instruments. Um, but it's sending back data, both of them, Voyager 1 and Voyager 2, on an occasional basis. And it's out in the area where the winds from other stars. I mean, it's tasting the winds of other stars right now. I mean, wow. We understand the wind from our star, but we don't understand winds of other stars and what they're like at all. We propose, we know, we theorize, but they're actually measuring it, which is really cool. Okay, so that's everything you sent me. Any other questions?
So, Jim, was that name of that show The Expanse?
Yes,
it.
The
Yeah.
Expanse. Yeah, I was going to
Okay.
say, I kept saying engage, and I knew that wasn't right. Expanse. Yeah. Now, for the first year of Expanse, I was a consultant.
Oh.
Yeah, so I helped them on a few things, and then they decided they didn't need me anymore, and went on to make several more years without me.
Does anybody have anything else, or we?
I heard you had fun on that show, Martian.
Yeah, I had fun on The Martian. That was really the craziest thing about doing The Martian is when you start working with the film industry and they want something and you're authorized to give it to them, you try to do that. And so we worked hard to give Ridley Scott everything he wanted. We advised him for weeks on end, for many months, and then he went away and did the film. I saw various versions of it when I was at a JPL. They'd say, "Well, next time you're out, come on down to Fox Studio and watch the next version of The Martian. We'll show it to you." Okay, great. Not thinking I'm going to see it 30 or 40 times in my lifetime. Okay. Because I talk about The Martian in many ways and then show the movie. So I've seen the movie a gazillion times. And so in all that, at the end, and they were going to take it for a premiere, Ridley Scott calls up NASA and says, "I want Jim to come to the premiere in the Toronto Film Festival." Well, the Toronto Film Festival is like the Cannes of North America. Everybody goes to Cannes in Europe, and a lot of movies are from the U.S. are shown at Cannes, but the Toronto Film Festival is all about films that are made in the Americas, in Canada, North America, South America. That's where you're going to see all those. Okay. And so NASA finally decided it was okay. And so Ridley said, "Well, I'll fly in a plane and pick him up." And they just freaked out. There's no way, there's no way he's going to fly on your chartered plane. So I had to put in travel orders, and so I flew economy up to Toronto, and then he said, "I want Jim to stay in this hotel that we're staying in because I want him in these press briefings that we're going to do the next day after we show the film." And they looked, and it's well over per diem. No, he absolutely can't go to a hotel that's over per diem. So I end up, like I'm gonna find a room in a hotel in Toronto during the Toronto Film Festival. Okay. I'm like 15 miles, out of town. And we got a hotel out there. So then he wants me to go to the before the movie party. Okay. So a limousine pulls up, and I was doing something, and I was getting a little late, and I got downstairs and got in, and I'm looking, and the party started at 7 o'clock, and I'm going, darn it, I'm gonna get there about quarter after 7. I've known about this all day long. How come I can't get there at 7? That's when I'm supposed to be there, right? So I get there and walk into this huge room where they have a bar, and they've got people walking around with food and everything. I'm the first one there. This was like 7:15, 7:20. So by 8 o'clock, more and more people were coming in, and I just ate my way from one end of the place to the other. And at the far end was the potato bar. Now, if you've seen the movie, potatoes play a central role, and so they have to have a potato bar. So what they do is they have this martini-like glass, and fill it with mashed potatoes, and you can put whatever you want in it and just eat it that way. Meat and veggies, whatever it is, you just it's all in there with the mashed potatoes. So I'm over there at the potato bar eating away, watching people come in, and I wanted to. I hadn't met Matt Damon. Matt Damon came in late, stayed on the set did all his work outside in Jordan. I didn't go to Jordan, all that stuff. And so I never really met Matt. Okay. I met most of the other stars, but I hadn't met Matt. So I'm sitting there watching, looking at the door, waiting for Matt to come in. And here comes the chauffeur. He comes in, and he's looking around for me. I see him looking around. I don't know he's looking for me, but he's looking for me. And he's all running all over the place. No, I'm just chowing on potatoes. And he go, "Oh, there you are." He said, "Come on, you got to walk the red carpet." And I go, "What? Walk the red carpet? Are you crazy? I'm not even wearing my best suit. Why didn't somebody tell me I was going to walk the red carpet?" Okay, that's crazy. He says, "No, no, no, come on, come on, come on." So as I'm walking out, Matt Damon walks in, and I had a wonderful conversation with him. And then I gave him a NASA pin. Those pins are called meatballs. The little chevron and blue thing, and I put it on him, and so he wore it all day. And every interview he has where I can see he's got the NASA pin on, I know exactly the day he gave the interview. So I get back in the limousine, and they take me over to the premiere, and the red carpet is an L. So you've got a down L, part of the L, and you walk down it. People on one side, photographers on the other. You get down to the bottom of the L, and the other part of it is where reporters are, with the backdrop that is the Toronto Film Festival. So I get out of this limousine, and the announcer goes, or whatever it happened to be. Everybody's going crazy. They don't know me from Adam. They have absolutely no idea who the hell I am. Zero idea. So I'm walking down this thing, and I'm going like this. I don't know what to do. Do it, ingenue, or what am I supposed to be doing? Okay. So I just waved, and I walked down there. I try not to walk too fast because I wanted to make it look like I knew what I was doing. I got to the end. I got down to the end. And right at the end was a NASA photographer who I knew. NASA had sent somebody to take a picture of me walking the red carpet, and they didn't even tell me that. I didn't know that, but there he was. And so I got down there, and what I did is I went, yeah, like that. Now, Mark Watney does that twice in the movie. Okay, he goes, yeah, like this. Every camera in the place went, it's like that's what they were waiting for. Why didn't I figure that out? I could have done that the whole way. I didn't have to wait to the end. Then I turned the corner and had all these interviews. And then I got to the end of the yell, and they go, okay, we're going to put you in the green room. So I got in the green room. So I first went in the green room. There's food all over the place. It's movie food. It's milk duds. It's popcorn. It's all the great stuff. And so I'm just eating movie food. I love popcorn. So and everybody starts coming in. Andy Weir comes in and with his date, and he brought his mother. And Jeff Daniels comes in. So I talked to Jeff Daniels, and all these people are coming in, and so they said, okay, we're going to have to seat you. So everyone pile out of this, and here's my assigned area. So I had an assigned area. I didn't have an assigned seat, but I had assigned area. So my area, so this theater fits like, I don't know, 3,000 people. I mean, it's enormous. And you've got three sections down below, and we're in the balcony section. And there's three sections in the balcony. All the stars sat in the middle section, and I sat to the right, sorry, to the left of the stars, looking at the screen. And so I'm walking up the stairs, and there's Nicole Stott, one of the astronauts. NASA sent her. No, they didn't tell me that. She helped. I had her help me, and we worked together. And I'm going, God, who else is here that I've worked with? And she goes, Jim, Jim, Jim.
Oh, no. Can you hear us, Jim? Oh, man. I think we've come to the and I want to hear the end of the story.
To be continued.
Oh,
Well, there you are. We didn't hear
Oh.
the end of the story.
All right. Okay. Well, anyway, she had me go over and sit down with Patrick Stewart.
Okay.
Yeah. So I'm talking to Patrick Stewart like he's my best friend. And he goes, oh, you guys are so lucky. All the years I did Star Trek, we were in a stinking studio the whole time. We didn't get out, we didn't do anything. They just built sets. Oh, this is crazy. So then I walk in and sit down and watch the movie, and the next day we just had interviews all over the place. And the only other thing I'll say is they'd mix it up. It'd be me and Andy, or Andy Ridley Scott and myself, or just me. Whatever they wanted, that they would compose that. We'd go in the room, and then the reporters would come in, and they'd be in a big U around us and ask us questions. So Ridley Scott and I go in and sit down. Oh, Andy was there too, Andy Weir. And he turns to me and says, the goddamn studio wants me to cut 20 minutes out of the movie. So I had to do that. Don't buy the DVD, buy the Blu-ray. That's got the full movie that I want you to see. I said, okay, all right, thank you. So now that whole movie was virtually shot not in America. It could have been shot in America. And hopefully we can get some of that business back. But that was like 2014, 2015 when they shot it.
Well, hey,
Really
Jim, they're gonna kick us out of the library here in a minute.
I know. I'm just
this is
teasing.
so wonderful, though. We appreciate you and hope you'll do it again.
Of course. Oh,
And Judy
wonderful.
got your book over there.
I was told yesterday that they sold out in the United States.
Oh, wow.
And they're doing another printing. And I said, you better get going, because I'm going to be giving an interview in 2 weeks in the Planetary Society, maybe 3 weeks. And people are going to be buying it like crazy. So
Well, we'll
Yeah.
look forward to it.
I started that in 2020 and worked with Tashin and helped outline it and picked the images, and it worked out great. It's really quite a nice book.
Thank you for all you're doing. So
yeah.
we gotta go. They're gonna kick us out.
All right. Thanks so much. Take care.
Thank you so much.
You take care.
So, astronomy club member, can you help us put everything away?
Yep.
The black